So we're going to start using exponent notation in order to short form multiple multiplications or things that you have to multiply by over and over and over and over again. For example, if you were trying to take number 5 and you had to triple it 20 times, you'd have to write this times this times this times this dot 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 until you had 23s in a row. Now, I don't even want to write that, let alone have to think about it. And if I were to try and type it into a calculator, I'm going to miss one. I'm going to miscount. I'm going to hit add instead of multiply. It's just going to be a hot mess. So I need a way to shorten this process down into a single operation so that it's less prone to accident and it's way less time consuming. And the way you do that is by using an exponent notation. So if I want to multiply something by the number 3 20 times, I just put a 20 up there in the superscript. So that instruction there is telling me to take the number 3 and do 3 times 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 3. You get it up until I've done it 20 times. So I can shortcut that whole operation down into just these characters. So if I grab my calculator here and do 3 to the exponent 20, I get 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. Let's see where the 3,486,784,401. Now, if you can imagine having to type times 3 times 3 times 3 into this machine until you got up to that number, it would take forever. And this took about 6 seconds. So this exponent notation really speeds up repetitious multiplications. I guess I should finish the question here. Because once I've applied the 3 to the 20, I'm free to multiply the rest by 5. Which gives me 1, 7, 4, 3, 3, 9, 2, 2, 0, 1. There should be a 5 in the back there. Yeah, 05. Okay. So this exponent notation made that much faster to do than doing all the multiplications manually. So we're going to start using it on complicated expressions. And there's just a few rules we're going to have to figure out in order to take some shortcuts in order to speed things up. So I'm going to clear this off and I'll do a couple examples with you. So that there says take these two things, 2 times x, and multiply them by themselves 5 times. So if I write this out the long way, I would have 2x, there's 1, there's twice, 3 times, 4 times, 5 times. Okay. Now, if I have to do 2 times 2 times 2 times 2 times 2, I can actually do that multiplication either in my head or with a calculator. So I'm just going to pull them out in front. It's 1, 2, 3, 4, 5 of them. And the x's, I can't actually multiply them because I don't know what they're worth yet. So they're just going to pile up on the back. Now, if you look at this part here, this is just another repetitious multiplication. So 2 times 2 times 2 times 2 times 2, I could rewrite that as 2 to the power 5. And this mess here, I have an x times an x times an x times an x times an x. That's an x multiplied by itself 5 times. So I could just write it like that. And to finish, 2 to the power 5, put it in your calculator, that's 32, x to the 5. So it looks like this expression, if I wanted to make it less complicated, I could take it down to that. So I've simplified it. And if you look between this step and this step, it looks like if there are two things multiplying each other inside that bracket, and they are both to the same exponent, then you can just apply that exponent to each thing separately. So if I were to do one for you that's just a little bit faster without having to do all the steps in the middle, let's try maybe 3y to the exponent 4. If I look at this, I can see I have two things multiplying each other inside of an exponent, the same that I had up there, which means that I'm free to apply this exponent to both of those things, 3 to the exponent 4 and y to the exponent 4. And I don't necessarily need to write all this stuff out. All this is happening when I go from here to here. But if I know what the exponent laws allow me to do, I can just shortcut. So 3 to the exponent 4, you put it in your calculator, that ends up being 81. And y to the exponent 4, it stays as y to the exponent 4. So exponent laws mean this. Like you have to do all this in your brain, but what you need to write on paper is to just shortcut from this to this, applying the exponent to each piece individually. All right, so this one has two terms to it. It has some things here that are squared. It has some things here that are raised to the power 4. So if we do what we just did in the last example, this can have the square applied to it, and this can have the square applied to it because they're multiplying inside of this bracket. And this 5 can have the exponent 4 attached to it, and the x to the power 4 can have the 4 attached to it. 3 squared is 9. 5 to the power 4 is 625. And then I have an x squared here, and I have an x to the 4 here. Now 9 times 625, I'm not going to try that in my brain this time in the morning. 5,625. But this part here, that's an x times an x because of the x squared. And then it's an x times an x times an x times an x because of the x to the 4, which looks to me like an x times 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 an x. That's just x to the 6. So I can shorten that down to a single x with a 6 on it. So if you can start to appreciate why these exponent laws are handy, if you have an expression like this, which has the x's in two different places, they're under two different exponents, there's numbers and letters all blended together. If you can use the exponent laws to sort of sort that out, you end up with all the numbers in one place and all the letters in one place under a single power, which makes the algebra easier to do on this finished product. So I'm going to try one more of those. Let's maybe do 2y cubed, and we'll do 5y squared. So 2 cubed, y gets a cube, 5 gets a square, y gets a square. 2 cubed is 8. 5 squared is 25. And I have 5 cubed times, y cubed times y squared. That's 3 powers of y here, 2 powers of y there. That's a total of 5 powers of y. So 8 times 5 is 200 y to the 5. So it's the same process as this one. You just apply the exponents to everything that's in the bracket, and then you gather the numbers, gather the letters, and write them as a single thing. If you have 3 things in that bracket, nothing has changed. All of these pieces are multiplying each other together, so each one of them can have the exponent attached to them. And if I wrote it the long way to convince you, this says 4 times x times y multiplied by itself 3 times. So that's 4xy times 4xy times 4xy. And you can see there, 4 times a 4 times a 4, which is 4 cubed. An x times an x times an x, which is x cubed. And a y times a y times a y, which is y cubed. 4 cubed, 4 times 4 is 16, times 4 is 64, x cubed, y cubed. So it doesn't matter how many things you put in there. As long as they're all multiplying each other, then everything gets the exponent. The 4 gets the exponent, the x gets the exponent, the y gets the exponent. Okay, this one has an exponent inside the exponent. So to deal with that, I'm going to write it out the long way. I have a 3 and an x squared and a y all multiplied together, and then we're supposed to multiply this expression by itself 4 times. So 3x squared y, 3x squared y, x squared y, and 3x squared y. Okay, so I see a 3 times a 3 times a 3 times a 3. That's 3 to the power 4. And I see y times y times y times y. That's y to the 4. But in each of these brackets, there isn't a single power of x. Now there's 2 powers of x in there. So an x squared times an x squared times an x squared times another x squared gives me 8 of them in total. Right? That's x times x, x times x, x times x, x times x, 1, 2, 3, 4, 5, 6, 7, 8. So this simplifies as x to the 8. Now again, I don't want to have to write all this out every time. So if we try to think about what happened there, if I take x cubed and I put it to the power 5, I'm going to have to write these 3 x's 5 times. And if you write 3 things, but if you take 3 things 5 times, that ends up with 15 of them. So rather than write out that whole string, you can just shortcut by thinking about how many x's there would be. Right? A triple x written 5 times makes 15 x's in total. And you're allowed to shortcut that way. That's one of these exponent laws. So if you have one that's a little more complicated, like 2x cubed y to the power 4 to the exponent 6, well, the 2 gets an exponent 6. The x cubed gets an exponent 6. The y to the power 4 gets an exponent 6. 2 to the power 6 is 64. You work out that number there. A triple x written 6 times, that's going to be 18, right? 3 times 6 is 18. And a quadruple y written 6 times, 4 times 6 is 24. So you're going to have 24 powers of y. So the practice problems that go with this are just, there's not a lot of math here. It's just, can you use the exponent laws to take something that's an exponent in an exponent and write it more simply, or if there are numbers involved, apply the exponents to the numbers and sort out how many x's, how many y's there are. Good luck.